Good afternoon, everyone. For today's topic, as part of our review lesson, we will be talking about factoring. Factoring is the process of expressing, or sometimes we call it rewriting, the given numbers or quantities or expression, like algebraic expression. As the product of two numbers or quantities. And the idea of factoring was first introduced to you when you were in elementary grades. Like for example, during your elementary time, there was a topic where you are going to rewrite a certain number into a product of two smaller numbers, or that given number itself and 1. Okay, for example, you have here, for example, 4 as a given number. You can rewrite this one, you can express this number 4 as a product of two smaller numbers, or else itself and 1. Like for example, if we have 4, you can rewrite that one into 2 times 2. And these 2 and 2 are what we call factors of 4. And you may also have 4 times 1. Still, 4 and 1, or the number itself as given, and times 1. These two numbers, 4 and 1, can also be considered or are considered factors of 4. In elementary, we call this one, for example, the first 2 and 2, we call these two numbers as prime factors of 4. And the idea here is factoring. And you may also have 6. You can rewrite 6 as 6 times 1, or you may also rewrite 6 as a product of 2 and 3. So when you multiply 6 times 1, the result is still 6. And when you multiply 2 and times 3, the product is still equal to 6. So these are what we call factors of this given number. So in elementary, again, the idea of factoring was there already being introduced to you by your mathematics teacher. So therefore, the process itself is not something so new to you. And for this time, we will be talking about factoring algebraic expression. Okay, let's begin with the first type of algebraic expression, where we need to factor out. The first one is monomial, or shall we say common monomial factoring. Common monomial factoring. That means that in a given algebraic expression, there is something which is common in the first term and the next term. And that is what we call common monomial. And you need to factor that out so that the resulting factors are what we call a simplified form of the given. For example, you have here 2x plus 4. The given algebraic expression is 2x plus 4. So under common monomial factoring, you just have simply to analyze the first term and the second term. You have to compare if there is common between numbers or coefficient and the constant or letters. But obviously, the variable here is only visible or given in the first term, while the second term does not have any variable. So therefore, you cannot say that x has common x here also. And then after that, you compare the coefficient 2 and the last term, which is 4. And obviously, between 2 and 4, there is a common value. And that common value, we call that one as common monomial. And that is what you should factor out. Okay, so in this case, you factor out the smaller value. So when you factor out 2, the result, what is left here is only variable x. And bring down the operation. And then, when you factor out 2 from 4, what is, okay, the remaining term here is only 2. So that, when you multiply it back to the parenthesis, inside the parenthesis, that is 2 times x, the result is 2x. And 2 times 2, that is 4. So, 2 times the quantity of x plus 2 is what we call the factors of 2x plus 4. And at the same time, this is what we call the simplified form of 2x plus 4. Because sometimes in algebraic expressions, especially when you add, when you subtract algebraic expressions, sometimes you need to express your final answer as a factors of the answer, because that is the simplified form. Okay, another one. You may have this 4x and plus 3x. Okay, so this time for number 2 given, still under the common monomial factoring, obviously 4 and 3, if you are going to compare the first term 4x and the second term 3x, obviously between coefficients 4 and 3, there is no common value that you can factor out. So, in your answer here, as binomial, magpabili ang 4 and 3. And you proceed to the variable. As you can see, variables here, x is also found in the first term and the second term. So therefore, you can say that x as variable is the common monomial for 4x and 3x. So you need to factor that out. And of course, if you have a strong foundation on how to add algebraic expression, you can also see that 4x plus 3x can be added into a single number or expression. And you may have the result as x. Since you can add 4 and 3, the result is 7. Or simply, you can also add directly these two. Although the topic is factoring, but you can combine this directly as 7x. And we will talk more of this soon in our discussion. Okay, another one. We have the last one as possible. Supposedly you have 5x and then minus 10x squared, for example. Okay, so again, do not forget class that when you use factoring common monomial, you have to analyze and compare the first term and the second term. So you have to begin first in the coefficients like 5 and 10. So if there is common between 5 and 10, then you need to factor that out. That is what we call the common between 5 and 10. And obviously, the common is 5. And then, you compare also variable x in the first term and variable x in the second term. So as you can see, common or the variable is visible in the first term. The same variable is visible in the first term and the second term. So therefore, you can also conclude that x is also common in the first term and the last term or second term. The next thing that you're going to do is between the x in first term and second term, you have to factor out the variable that has smaller exponent. So between x here and x squared, the smaller is x because it only has 1 as exponent. So this is the x that you need to factor out along with 5. And after that, when you factor out 5x, the remaining term for this first term is only 1 since you have factored out 5x. And then minus, when you factor out 5 from 10, the value that the coefficient that remains here is only 2. So that when you multiply 5 times 2, that is 10. And when you factored out x from x squared, since the exponent is 2, so obviously, there are 2x here. So since you factored out 1 of these 2x, so what is left here is only 1x, or the remaining x. So that, how are you going to check if these are the required factors of 5x minus 10x squared? So just simply try to multiply it back inside the parenthesis. That is 5x times 1, the result is 5x. And then 5x times 2x, shall we say 5 times 2, that is 10. And x times x, that is x squared. So therefore, plus 5x and the quantity of x minus 2x are the factors, complete factors of 5x minus 10x squared. So these are just among the expressions that can be factored using a common monomial factoring. There are plenty of algebraic expressions where you can apply the common monomial factoring, and these are just few of them. So after the common monomial factoring, let's proceed to the second type of factoring. We have difference of two squares. So difference because the operation is minus, two squares because there are two perfect square expressions and or numbers involved here. Basically, for example, you have x squared minus y squared. So this is the illustration of difference of two squares. So difference because minus, and two squares, it refers to the two terms that are perfect square. For example, you have x squared, and y squared. So the first perfect square and the second perfect square. That is why they are called two squares. And the process is just like this, if you can master the technique. So to factor out difference of two squares, the resulting factors are two binomials. And when you factor out difference of two squares, just follow this technique, you have to first analyze if the first term is perfect square and the second term is perfect square and there is no other next term. And between the two terms is minus. That will be the time that you have to think if you are asked to factor out algebraic expression if the given is difference of two squares. And when that happens, just simply follow these techniques, class. So x squared minus y squared, when you factor this out, the resulting again are product of two binomials. Just simply, just distribute x. Okay, so x and x refers to squared. And after that, distribute y and y. And in your first binomial, use automatically, okay, the first given operation. Then in your second binomial, take the opposite of minus, the reverse of minus, which is the plus. Okay, so that's it. When you factor out difference of two squares, like x squared minus y squared, the resulting factors are the product of x, the quantity of x minus y, and the quantity of x plus y. Just follow that technique and it will make your process shorter and simpler. Okay, for example, let's try to use another value for difference of two squares. For example, if you have x squared minus 1, for example. Take note, class, that 1 is the smallest perfect square number. And obviously, x squared is perfect square and the operation is minus, so therefore, this is difference of two squares. And when you factor that out again, the resulting factors are product of two binomials. So just simply follow the technique. You just have to distribute x. Okay, don't think any other else. Just distribute x. Then after that, distribute 1 here. So when you multiply 1 times 1, that is 1. And for the first operation here, just use the original, which is minus. And for the second binomial, take the reverse or the opposite of minus, which is plus. So simple as that. So that's it. When you factor out x squared minus 1, the resulting factors are the product of x minus 1 and x plus 1. Or simply, the quantity of x minus 1 times the quantity of x plus 1. And maybe you are confused and maybe you have this doubt in your minds. Is it really correct that the factors of x squared minus 1 are x minus 1 and x plus 1? Just simply, class, you can check your answer if it is correct. Just multiply your factors. Multiply x times x minus 1 and x plus 1, like this. So simply, if you can still recall, x times x, you just copy, bring down x, and other exponent, that is 2. And multiply x times 1, so any variable multiplied by 1, the result is the variable itself, that is x. And opposite sign, this is positive, and technically this is minus, negative or minus, so just copy, minus. And you multiply 1 times x, that is, okay, x. And plus and positive 2, so technically the same sign. So this is plus or positive. Just remove the positive sign. And when you multiply, after that, 1 times 1, that is 1. And since their operations or signs are opposite, so you just have to use the minus operation. Then bring down x squared. And when you add to the same quantities with opposite sign, the result is 0. And bring down minus 1. So, your final product is x squared minus 1, which is also the given. Okay, so just simply no need to, when you do it yourself, plus no need to multiply your factors for you to check if the result is the required factors. Just simply remember and follow the technique. Okay, last one for this difference of two squares. You may have x squared minus 4. Again, always compare the first term and the second term. If the first term is perfect square and the second term is also perfect square, and their operation is minus, so that you can conclude that the given is factorable, under difference of two squares. Okay, just simply follow again class the technique. If difference of two squares, the resulting factors are product of two binomials, just distribute x and x. And then the factor of 2, okay, although the factor of 2 has the factors of 4, the factors of 4 that will give you the resulting x squared minus 4 when you multiply this factor back to recheck if these are the required factors. Just simply use 2 and 2. Because again, class, you can factor out 4 into 2 times 2, or you can also factor out 4 times 1 here. But the required factors that will give you the result as difference of two squares back to the original x squared minus 4, the only factors that you need are the product of x, okay, minus 2 and x plus 2. So when you multiply this x minus 2 and x plus 2, the result is x squared minus 4. Because, okay, so supposedly you have this in mind. What if, sir, why not use 4 and 1 as the resulting factors here as x plus 4 or x minus 4 or x minus 1 or x plus 1? Okay, just remember this class. The difference of two squares, when you factor that one, the next thing that you always remember is that in factoring this difference of two squares, while the first term and the second, the first binomial and the first term of the second binomial, these two first terms in your factors must be the same. And also, the last term in the first binomial and the last term in the second binomial must also be the same numbers or quantities. Okay, so that's it, class. That's how you factor out difference of two squares by simply following the techniques. You don't need longer solutions to present to your classmate or to your teachers if you are required to factor this out as part of your assignment. Okay, so we have 1 and 2 examples for difference of two squares, and I guess that would be enough for you to recall and to refresh your knowledge about difference of two squares. Okay, so after the difference of two squares, we may have okay, so when we have sum and difference of two cubes. For the sum of two cubes, we have this x cubed plus y cubed. And for the difference of two cubes, we have x cubed and y cubed. So that is why they are called sum and difference of two cubes. So sum, the operation is plus, and two cubes, that means the first term is perfect cube, and the second term or the last term is also perfect cube. And for difference, okay, x cube, perfect cube still for the first term, and the operation is minus, that is why it is considered difference, and the y cube as the second term. And why is it, you have this question again, why is it there is no third term or last term? Why is it the given is only binomial? Simply because we talk about two cubes, two terms only being involved here, which is the sum of two cubes, and the other one is difference of two cubes. Okay, how are you going to factor if the given is sum of two cubes or the given is difference of two cubes? Okay, so just simply follow this one, guys. For example, you have for the sum of two cubes, x cubed plus y cubed. So to factor this one, use the shortest possible technique. To factor out, so when we say x cubed, it means that for x cubed, it is equal to x times x. There are 3x that we multiply to get x cubed. The same way, y. Or if you have y cubed, it means it is y times y times y. Okay, so to factor this out, class, just simply get the cube root of x cubed, meaning the first x, as your first factor. By the way, when you factor out perfect cube or sum of two cubes, the resulting factors are the product of binomial and trinomial. So that means your second factor is trinomial, while the first factor is binomial. Again, for a factor of x cubed plus y cubed, when you factor this expression, the resulting factors are the product of binomial and trinomial. So therefore, the first factor here is as a binomial, there are two terms, and for the second as trinomial, there will be three terms as the next for the second component factor of x cubed plus y cubed. Okay, going back, so again, for the binomial, just get the cube root of x cubed or the first x here, and then for the second term, just also get the cube root of y or the first y of the y cube. That is the second term of your binomial as the first factor. And then use the original operation, which is plus. Okay, that's it. You have now your first factor, the binomial part of your factors. Let's proceed to the trinomial part of the factors of x cubed plus y cubed. Okay. The same, the first term is x, the last term is y. And this time, what will happen here is that for the first factor, which is binomial, you have factor out the first, the cube root of x cubed, which is x. So, what remains here is x squared. That will be your second Okay. The first term of your second factor. And for this cube root of y cube, which is the first y, the remaining y here is a y that has a second y raised to the power of 2. So you have here, you have to raise it to the power of 2, your y, or the last term of the trinomial as the second factors of x cubed plus y cubed. And then, your problem now is how to obtain the middle term. Then after that, providing the first term and the last term, you proceed to the middle term here. So, how are you going to obtain the middle term? Just simply multiply x and y. So when you multiply x and y, the result is x and y. And then, after that, you already have used the original operation for this binomial. And this time, you take the opposite of plus, which is minus, and use that one as your operation between the first term and second term. Then after that, for the operation here, use the original given, which is plus. So therefore, thus, when you factor out x cubed plus y cubed, the resulting factors are the product of the binomial and trinomial. And these are the quantity of x plus y times the quantity of x squared minus xy plus y squared. And for example, you have here, supposedly you are going to factor out x cubed plus 8. So obviously, x cubed is perfect cube and the operation is sum. And of course, 8 considered as perfect cube number because 8, you can rewrite that one as 2 raised to the power of 3. So therefore, it is perfect cube. And let's proceed to factor out, to provide what are the factors of x cubed plus 8, you may rewrite this expression into x cubed plus 2 raised to the power of 3. Still, if you multiply, if you simplify 2 raised to the power of 3, that is still equal to 8. You are just rewriting the constant term into a power of 3 so that the exponent here will be the same as the exponent in the first term to perfectly illustrate that this first term and second term are perfect cube terms. And we have now the sum of two cubes. First cube, first perfect cube and second perfect cube, and the operation is plus. So just follow plus, remember the technique. The first of your factors is binomial and the second factor will be trinomial. Okay, so simply for the binomial, you just have to rewrite or distribute x, the lowest or the third or the cube root of x, cube, which is the first x as I said earlier here. And then 2, you have to, that means 2 cube, it means that you have to multiply 2 times 2 times 2 by itself 3 times. That means you are going to place here the cube root, which is 2, and then use the original, which is plus. Then after that, for the second factor, which is trinomial, you just have to again write x here. And since you already have factored out the first x here, what remains is the x squared. And then After that, for the last term here, the remaining will be 2 times 2, or simply, if you multiply that one, that is exactly 4. Or you may say that is 2 squared, because you already have factored out the first 2 from 2 cubed. Okay. So the remaining will be 2 squared. And then again, for the middle term, you just have to multiply x times 2, and the result is 2x. And remember what I said earlier, that for the operation here between the first term and the second term, just simply get the opposite of this plus, and that is minus. You use that one as the operation between the first term and the second term. Then after that, for the operation here, just simply use the original operation, which is equal to plus. So therefore, your final factors will be x plus 2, and the second is x squared minus 2x. And since this is number, you have to simplify that one into 4. So you have now your factor, the complete factors of x cubed plus 8. And that is, the first is x plus 2 times the second factor, which is x squared minus 2x plus 4. Okay, so I hope that will make you easier to understand, and in your future mathematics lesson, or if you have done with this in your previous lesson in your school, at least you can have the repressing lesson or discussion using this review topic. And this time, we will proceed to the factoring of the difference of 2 cubes. So how are you going to factor that one for the 2 cubes? Okay, so we have here, for the 2 cubes, the difference and for this type of factoring, we have x cubed minus y cubed. So 2 cubes, and the operation is minus, so it is difference of 2 cubes. To factor this out, just simply again, the resulting factors are the product of binomial and trinomial. And for this factoring, the same process as the sum of 2 cubes, only that there is a slight difference in terms of operation. The same if you are able to master the technique there in sum of 2 cubes, just simply again use the cube root of x cubed, that is x, and the cube root of y, that is y. And then use the original operation. Then after that, you can also get the first term and the last term by doing this process plus. Just simply square the first term, which means for this x, just raise it to the power of 2, and you place that one here as your first term. And again, for the last term, including this operation, you may have y, and then raise it to the power of 2. The result, when you square negative, it is automatically positive, and when you square y, that is y squared. So obviously, negative here becomes positive. So since it is positive, automatic, it is plus. And that is for the sum of 2 cubes. Just remember that one. And after that, you multiply x times y for the middle term. So x times y, obviously, that is xy. And for the operation between the first term and the second term, okay, you just have to get the opposite of this operation or sign. So since it is minus, okay, the opposite of this one is plus. So therefore, your complete factors of x cubed minus y cubed are the product of x minus y as binomial and this times the second factor, which is trinomial, x squared plus xy plus y squared. So that's it. That's how you factor out x cubed minus y cubed, or difference of two cubes. Now let us use another example. This time, supposedly you have x cubed minus, minus 8. The same in sum of two cubes, only that we change the operation here. Okay, so just remember, the cube root of x cubed is x, and the cube root of 8 is 2. And then use the original operation or sign, which is minus. And for the second, here, which is the trinomial part of the factor, is you just have to square x squared. So for this x, raise it to the power of 2 and place that one as the first term of the trinomial. And including operation minus, considered as negative 2, you raise it to a power of 2, and then the result will be 4. Or simply, okay, 2 squared, or just simply directly, that is 4. When you square negative, the result is positive. 2 squared, that is 4. You place that one as your last term. And since we square negative, the result is positive automatic, that is plus. And for the middle term plus, you just have to multiply 2 times x. So 2 times x, the result is 2x. And for the operation here again, you just have to use the opposite of minus. And the opposite is plus, and use that one as the operation between x squared and 2x, or between the first term and the last term. So therefore, plus, when you factor out x cubed minus 8, the resulting factors are the quantity of x minus 2 as binomial times the quantity of x squared plus 2x plus 8 as the trinomial part of the factors. Okay, so that's it. That's the basic part on how you factor out the sum and difference of two cubes. And we will have a short break, and we will continue after 5 minutes break for the second or the third type of factoring. Okay, so you can take your break now.